Good morning, good morning. Today some information concerning my work in Egypt since last 40 years at various sites. We will start in Heraconpolis in Upper Egypt. This is American Polish mission conducted by Elizabeth Walters from Penn State University, Pennsylvania State University. So this is area of work near Itfu. There is an area where is site Heraconpolis. There is geology of this region by Said, Geology of Egypt book, and as we see, there is quaternary table limestones and small pieces of Cretaceous limestones. Area look like this. There were the excavation. It's group of workers together with chief of expedition. They work in one of trenches. They don't work too much, but there are workers, pottery from site, and documentation, etc. We did boreholes for determination of geology at this area, and site is localized at the edge of Big Wadi, now dry Wadi, and at cultivated zone, and these various marks. There are limestones, table limestones, agriculture, fields of agriculture, sands removed by waters in the past from this wadi, and archaeological area. As we see, location of site is just in front of wadi, so this means that wadi didn't transport water. In other case, these all monuments, archaeological monuments, will be destroyed. So there is drawing from literature, schematic showing elements of New Kingdom and Old Kingdom, archaic, and below, under these traces of constructions, there are Neolithic layers. And boreholes we did, there are numbers of boreholes. This give picture very complicated because there is activity of wadi before drying of the climate, activity of the Nile, activity of the man, human activity at various times. So we obtain picture like this. There are descriptions, very complicated, difficult for explanation. Cultures Nagada 3 and Nagada 2, there are pieces of pottery, of vessels, red polished, as you see, and other. We did examination of this material. There are broken walls. It's seen that they were burned at oxidated atmosphere or sometimes reduced atmosphere. Under microscopy, mineralogical microscopy, structures of ceramic mass look like this. some of this ceramic mass was used directly for preparation of vessels. Some were prepared specially where was added quartz, natural rounded from the desert or crushed like this. Under microscopic observation at Cross-Nichols mineralogical microscope, structures of ceramic mass of pottery Nagada 2 and Nagada 3 look like this. As you see, there are big differences. Some of materials used for preparation of pottery were local, and some were taken from other places, not local. This is example of results of examination of pottery, Heraconpolis, Egypt, Heraconpolis, pottery number 6, macroscopic features, temperature of firing and mineral composition, and grain size composition, and Heraconpolis sample pottery 10, you see, and there are differences between this ceramic mass. So, of course, there are stone objects, and there are drawings of damaged stone objects, small plate, which look like this. There's the reconstruction and cross-section. Next, small plate, flat, with traces of damage, and rounded vessel, stone vessel, and next stone vessel. Most of object is very strongly damaged, and there are examples of flint implements found in layers Nagada 2 and Nagada 3 layers, scrapers and flint cores, pistol for grinding of material, flint core. Next, beginning of work on this flint. And there is a petrographic determination of various rocks, objects found in Heraconpolis. Sandstone conglomerates, mainly are sandstone present. Quartz is present, used for various products. And whole area is covered with salt, because still is going evaporation from the ground of the water, and from this evaporating water are crystallizing salts on the earth, on clays, and on various flora and other scanning microscopy. Look like this. There is halite and ACL, and there is trona present too. Not too much, but there are. Second region, this is the region of Armant. We worked there a few seasons. I was concentrated on geology. There is local profile, Sahaba formation between these arrows. Under microscopy, these minerals of Sahaba formation look like this. There are mostly clay components, kaolinite and illite, quartz and some feldspars and iron oxides. This is important for understanding of phenomenon present, geological phenomenon present in Nile Valley. There is cross-section across Jebel and two zones, and zones, flood zone, flood plain, and Nile. So this region, this is typical mountain morphology, and in the past the river flow from this Jebel elevation very fast and transport big gravels. These blocks were deposited at these zones. Are deposited Theban limestones, secondary position, red soils removed from Jebel, and Kena sands with data about 400,000 years. And this is an interesting place because this is area of intercalation of sediments from Jebel and from Nile. When Nile was high, the water was great, this plain was covered with water and were deposited sediments of Nile. When were locally rains, material was transported from Jebel to this area, so there is intercalation of Nile sediments and Jebel gravels transported from Jebel. This area of presence of the sites, archaeological sites, Neolithic, slightly elevated area about floodplain is plenty of sites. We investigated this one. And this site, it's marked there, is located off Old Wadi, dry now, of course, where deposition of sediments look like this. There are numbers, 15 number, and 15 profile from this place, 14, and so on. And as you see, there are gravels with sands transported from the Jebel. Of course, when rain was big, were removed and transported coarse gravels. When rains were weak, delicate, were transported sand. So it means that if we have elements for C14 datation, like for example piece of wood or sometimes fragments of pottery, we may determine more or less precisely when were heavy rains were transported these blocks, or sometimes rains delicate transporting sands. So these pictures are very useful for reconstruction of the climatic changes in the past, and they are useful for determination of relation between rains and human activity. When was dry, people from the desert, from Sahara, migrated to this place and to this area limit of cultivation. They see there a river transported water were a completely other climate. And next, if the climate change, they don't use local water, they take water from the Nile, took water. This is an example of stratigraphy from this area near Armant. there is full sequence of various sediments, Aeolian river, human activity for long description and discussion, of course. Deir el Bahari, Upper Egypt, we work together with German mission and Polish-Egyptian mission since long time. This is general map of Deir el Bahari. Marked are places of archaeological objects, architectonical objects, etc. So there are elevations, there are direction of flow of the water. In the past, before temple 1 and 2 temples were created, were built. And there are Theban limestones and young sediments, this white without marks. Interesting is Lassim, the mountain above temples of Hatshepsut, that Thutmose III, because this Theban limestone at this area contained plenty of flints used in the past, in the Stone Age, and even later. Starting from the bottom, from the contact between Esna shells and top of Lassim mountains, we have following types of flints. I did examination of the profile. I collected samples. They were polished. The same flints we can find in young sediments. They were taken for preparation of stone vessels. And this is Hatshepsut temple, and I work on the geology of this area and the reconstruction of the process of construction of temple. This is upper part of the temple, entrance to the sanctuary, and photos of the in front of the second terrace. This is seen, this grade, this is place where Theban limestones were removed, and in part Esna shells were removed, and they were collected under this cover, artificial made using plates of Theban limestone. So from this material was transported there. And the temple, lower part of the temple, is constructed on the top of Esna shells, as you see, even slightly natural profile of Esna shells were prepared for construction. Later were prepared type of steps, were put blocks of limestones, not very solid, and next solid wall made of stones. There are stages of preparation of construction of the temple. The figure A, is before construction of temple. So we have local young gravels, Esna shells with intercalation of limestones and Theban limestones. And next, first stage of construction of temple, this part of material natural slope were removed and put under lower part of temple. And next stage of construction of the temple, when we have completely changed morphology, and when we look for cross-section, this is cross-section at place of presence of temple. Theban limestones, Aetna shells slope along this line A. And B, this, it's when were cut Aetna shells, were left plates, layers of limestone, and again Aetna shells were removed, like see, and left in front of the temple. And next stage, it was better seen there. It was work in Aetna shells where carving were carved corridors, and layers of limestone were used as the roof of most of chapels and constructions under the layers of limestones. So it was very clever because they use natural layers of limestones as the top of constructions made at Aetna shell. So we may say that temple of Hatshepsut is the object, architectonical object, with 2 or even 3 floors, levels of activity, of human activity. And we did examination of various colors, pigments used for painting of walls in temple, taken very delicately from surface of the blocks. And we did various examination of these paintings and this various color material. And this is infrared spectrum of one of components, and under scanning microscopy, these various paintings, various colors look like this. And what is interesting that for painting were not used grinded material, but was used crushed material, very fine. And there are local pigments discovered in Aetna shells. There are nodules containing hematite, jarosite, and various other minerals. This is, for example, natrojarosite, yellow. X-ray examination showed that there is basanite, there is kind of gypsum, calcium sulfate, sometimes traces of quartz. We did artificially at lab various pigments using local minerals discovered in Aetna shells. It looks like this. There is description, and there is identification of minerals used for paintings in Temple of Hatshepsut. You may see some words. Sorry, it's not sharp, but it's old photo. There is some information about tombs investigated by me since long time. It's tomb where worked tomb Tomasz Górecki from Polish mission, very interesting. It was dug at about 1800 years before Christ. And there is tomb under the temple of Hatshepsut. We went down is small cave, small room, dug in Aetna shells. There are Aetna shells with veins of light calcite and gypsum. That is present too. This roof of this place is not in good conditions. There are pieces which fall down from the roof. And there are some examples of various way of digging of tombs in the area of Theban Cemetery and Valley of Kings. They were dug in limestones next in Aetna shells, like this, next Aetna shells, limestones, and they were dug in gravels, Eocene conglomerates, and in conglomerates and next in Aetna shells, depends on geology, local geology, vertical and horizontal, etc. Interesting that most of tombs were dug in limestones and in Aetna shells using practically mining technology, and product of this digging is easy to discover in front of tombs. There is plenty of small flakes obtained during the cutting of walls of corridors, preparation of tombs. Castle Saga is Polish-German mission. We work at this area. This is Fayum Lake, Fayum Oasis, Nile Valley. And this geology of this area is slightly complicated. Theban limestones, tertiary claystones, mudstones. This is the same what we have in Upper Egypt, is Aetna shells. And there are young sediments, quaternary sands, gravels, etc. It's by Rushdi Said, 1966, Geology of Egypt. Area look like this, and cliff representing sandstones look like this. This is bottom of old Moeris and Paleo Moeris lake. This is rest of petrified wood, Eocene wood petrified with the quartz, and chalcedony was used sometime for preparation of implements. Mostly they used flints, but sometimes they used this petrified wood too. There are interesting basalt covers over the sedimentary rocks. This is geology of old sediments of Birkat Karun Lake, Paleo Moeris, light sands, and all geology was determined during our work at this area. A sequence of sedimentation were discovered, a lot of archaeological sites, Karunian, Neolithic, of various age, and even from kingdom, dynastic sites were present on the Jebel. There is plenty of tombs, and according to our work, we construct the reconstruction of oscillation of the lake, Moeris Lake, according to rains and drying of the climate. There is a scheme showing this process. Saqqara. In Saqqara I didn't work personally, but I obtained materials from Professor Myśliwiec, Karol Myśliwiec, and many interesting things. Between other, we did examination of small finds of salt covering bandages of mummies. There are X-ray diffractometric analysis of these salts. As you see, mostly halite, sphalerite traces, but maybe calcite, and thenardite, and quartz halite, trona. Some information about examination of bandage of mummies from Old Kingdom. There is a large photo of structure of bandage, and bandage which was damaged by microorganisms. Look like this destruction, and under enlarged under the microscopy, this structure of bandage primarily will look like this, completely damaged. It's interesting that on some fragments of bandage we discover pieces of green plates, small plates. There's about half of centimeters, maybe slightly more, and there is skin of mummy, white green. We did examination, and we find chromium. In the past, where for conservation of dead persons, there was used chromium as material used for conservation of collagen. Up to now, organic products made using skin, belts, and other products are fixed using chromium. Sorry. It's interesting from where they know in the past, in Old Kingdom, that chromium is conserving skin, because it's evidently chromium used. There is a large fragment of the bandage was damaged by microorganisms, and chemical analyzed using ADS method what is inside: calcium, chlorium, sodium, so nothing special. And this is again bandage with microorganisms, this and this various, and it's calcium, aluminium, chlorium, iron, and it's phosphorus. Phosphorus most probably from the organism of mummy. And because presence of green plates of skin, we did biological, histological examination of this skin. Was done by specialists, and this green fixed using chromium plates of skin from Old Kingdom look like this. This is my colleague working on this. He didn't find any special characteristic features for illness or something like this, normal. And there is analysis of the bandage of one of mummy, and we have phosphorus and all three groups, chlorium, sulfates. And this is diagram showing chemical composition of bandage from tomb 404, All Kingdom, Saqqara, examination of Professor Karol Myśliwiec, and it's seen that extraction using various substances help to determine various components present in bandages. Plumbum, it's galena, most probably zinc, copper, manganese, iron, and chromium, and nickel, traces of nickel. It's interesting determination of isotopic composition C13 from samples from bandages of mummies from various tombs. There are numbers of tombs, and there are C13C carbon data. You see how these microorganisms after death of person and after use of various bandages, they change isotopic composition of bandage, starting from 15 up to 24. It's a great difference. Of course, this is because of activity of microorganisms, bacteria, fungi, various, etc. Tel El Faha mission, Polish-Egyptian mission, localized at this place, conducted by Professor Czałowicz and Professor Marek. I participate in some seasons. This is area exploration in front of buildings on big gazira. We do boreholes, geological examination, and this is a sequence of drawing showing the sequence of phenomenon of the edge of gazira. Zero, this is level of sea, and we may observe how area around the gazira were filled up with silt of Nile. One, no silt, then silts up. At the end, we obtain situation like this. Gazira covered with first layers, Neolithic Nagadian layers, and next over the geysera were constructed architectonical objects, etc. And at the past, people sit at the Farka on the edge of geysera. There was small river, now it's canal, and they had water for life. And of course, it was construction and destruction of architectonical objects. History, it's not my business, history, archaeological. So especially interesting, there is intercalation of Nile silts with archaeological layers, because sometimes Nile was high and sediments cover archaeological layers, and sometimes Nile was lower and anthropogenic sediments containing various objects cover silts of Nile. So we have situation Nile anthropogenic, Nile anthropogenic, and on the end the site was many stages of functioning of the site, and next site was left by humans. This is one of examples, many examples of reconstruction of architectonical object observed in profile. There is wall constructed on various sediments. These sediments are marked as 13, 20, 11, and so on. And over these sediments were built wall made of dried bricks. Next, this wall was damaged at a few stages, and around this damaged wall were deposited sediments, number 6, 5, 3, 3, and 4, 3, and at last this damaged wall were completely covered with younger sediments. This type of reconstruction is very helpful for understanding of functioning of various places in archaeological sites. In its next example, wall, first stage of construction of wall A, B next destruction, dried bricks were damaged by rains, and next stage of destruction, and later sedimentation of surrounding sediments. There are examples of archaeological works and discovery of dried bricks walls, and we know we did mineralogy of these dried bricks that there are various sandy and more containing more clay, etc. This is important. Mineralogical determination of these bricks is important because of correlation between constructions, between buildings, because at the same time at various places of the site they built objects using dried bricks of the same kind, of the same mineral composition. This means that dried bricks and mineralogy of dried bricks may help to understand development of the site. where at the past houses were built, where at the past other houses were damaged. It's very complicated, but knowledge concerning mineral composition of bricks may help for reconstruction of the past. And this is example of the reconstruction of human activity in Tel El Farha in the past. This is a geological profile of western wall trench in central Qom, and there are stages of development of human activity, starting from this place. Late at the beginning, sands of Gezira, first archaeological layer, first archaeological structure, wall, and next this wall was damaged and were built new walls, where these walls were destroyed, damaged. We don't know why, by humans or by weather, the rains. Next stage, next building at other place, next, and next, and next, and up to now how it looks like. For determination of human activity at various places of the same site, these reconstructions are very helpful. And this is an example of one geological profile in the southern wall of Qom, central Qom. As you see, plenty of phenomena, bricks, not bricks, damaged layers, etc. We did cross-section, and we determined presence of charcoal, small pieces of burnt clay, fragments of fish, and fragments of flints and other rocks. And we, on the base of this, we construct small map of presence of charcoal on the one of levels. And as you see, there are places not seen macroscopically. There are presence of higher concentration of charcoal. And concentrations of bones. There are places of concentrations of fish bones near probably fireplace, not seen absolutely. So these micro fragments of various documents of human activity, charcoals, bones, small pieces of flints, etc. If we do maps like this, we may determine more precisely phenomenon in the past. And there is cross-section and drawings showing changes in one profile, concentration of charcoal, bones, flints, quartz, and I don't remember exactly what it was. But as you see, during deposition of these anthropogenic layers, at the same place, one, we have great concentrations of bones. Next, we have concentration of older, we have concentration of flints. Next is concentration of microflakes of flints. So this means that at the same place at various time, they did in the past various things. They did fireplace. There was fire. Next they did something with the bones, and so on, so on. And this is an example of one of Tom's with beautiful pottery, and observing these small fractions, we find hematite. This is macroscopic picture. This is using polarizing light microscopy. Archaeologists find vessels of various size with dark black spots. After examination, there is photo of this part. We discovered that this black substance, this is type of asphalt. In the past, at this time, they did not know covers to cover the vessels, and they use asphalt to cover substance saved, collected in this vessel. So when during time this vessel was turned, and this vessel and the asphalt from this covering cover flow down, coating the wall of vessel. And interesting, there are very diversified flints used for preparation of various implements in archaeological site of Deir el Bahari. They were examined using mineralogical methods, sickle blades, small agate of various origin used as material for napping. Of course, this is not my business, what is what, but it's interesting. We did observation of working edge of some selected implements, flint implements, and using scanning microscopy, and in very small fissures produced during work of these implements, we find secondary mineralization with iron oxides, traces of phosphorus, and many other interesting things. There are finds made using copper. More details in archaeological material. We did examination of this copper using scanning microscopy, and we used pictures of secondary form minerals, phosphates and sulfates of copper, covering this damaged surface of this implement, very beautiful aggregates of flints. So more or less it's at the beginning all. So thank you for listening, and see you inshallah in the future. Thank you very much. Masalama.